Hello everyone, this is Priyanshu Gupta here. First of all, welcome you all to this video of system design for starting up. This video is for all those who want to create a growable, scalable and reliable and robust system for their startup, and also for all those who want to learn how to design a real-time product from scratch. So basically what happens is when you start up, you want to create a MVP of your product, right? To let the users use that first and take the inputs from that and then actually investing in it. And here comes the challenge, because you want to give your users a lot of features at the minimal cost and with minimum resources. So that is what we are going to solve in this video. And this video is also for those people who are just creating a project for their colleges or want to create a real-time product. Because right now you might be creating a normal project for you, but later on when you will actually work in a startup or a product-based company where you will be working on the real-time products, you will be knowing everything, like how to start from scratch. Okay, you might have seen a lot of videos on YouTube and a lot of courses on system design where they will be teaching about a lot of microservices, like in big applications like Netflix, WhatsApp, Instagram. These all are big companies, all right. These are well established companies and they have a lot of money. So they can spend on their infrastructure and lot of microservices, right? But you can't do that. So this doesn't make any sense when you are starting up. So the goal of this video will be to design a system for a MVP, but we will design it in such a way that it is highly growable, scalable and robust. Okay. By growable, I means that like in starting you will be giving some limited features, right? But later on when you have fully tested your application and you know that users are willing to use that, then you can actually add more features into that. Basically you can add those modules inside that, and because of course that will increase the cost of maintenance and all that stuff, and also you will have to invest on the infrastructure, right? Because when you start up, right, you want to invest as little as possible, because at that point of time you don't know how your product will actually perform, users will like it or not. So if you have money, then you're good to go. But generally what happens is people try to put as little money as possible and then see how it is performing. And people generally face in starting only, like how should they start up actually, how should they create their system, how to create the backend and front end and link everything together and give it to the users. So here I will share my experience and give you the best options available so that you can design a best system for your use case. And the system design is not like fixed set of rules that you can follow, like step 1, step 2, step 3. It is like hit and trial method. You have to basically explore a different paths and choose the right path for your situation. But I will try to generalize everything and we will try to explore a lot of ways through which you can actually create from a starting product, then add features to it and then scale it to serve high traffic volume. So in this video what I will do is I will take an example of a real-time use case, and basically we will try to design the system for that, and we will try to do it in such a way that I will think that you are creating an MVP for that, and then you also want that to be highly scalable also. So first we will try to create a system for an MVP, and then we will try to add more features to that, and then we will also scale that so that we can serve a high traffic volume. Okay, so let's get started here. So I am taking an example here of a social web application which is like Instagram and LinkedIn, and I will try to basically first list out the functionalities that we want. First functionality that we want is basically authentication, because every technical application that you will create, of course it will require some sort of authentication, right, to basically authenticate that user. So first is authentication. Second, since it's a social web application, you must be able to post something over there, right? So second is post. Then third functionality will be likes and dislikes. Fourth will be comments. And fifth will be user feed, right? Because when you open your Instagram or LinkedIn, you see the post of those who you follow, right? So basically we will try to design that also. That is user feed. And then we will try to add one more functionality that is called as notifications. Suppose let's say the person you follow put some posts, right? So you will get a notification that this user has posted something, or any kind of notification, right? So notifications, and also we will try to add one more functionality that is called as payments, because this is very important, right? Because you have to test that your users are willing to pay for the service that you are trying to provide. So this payments is basically like what we will try to resolve here is, like, suppose let's say this payments can be anything, right? But just for our use case, the social web application, what we will do is we will try to add a feature that is called as like suppose in LinkedIn we have premium thing, right? Like LinkedIn premium. So user pay some fees monthly. Basically it's a kind of subscription model. So for that user pay something to LinkedIn and they give some extra features to those users. So we will try to add that payments feature. We will not of course cover everything in that, but we will just include like the normal payment procedure inside that, so that we can create a robust payment system. Now to start with, what we will do is we will first try to figure out how the data is and what kind of database that we have to use. So databases can be SQL, NoSQL, document based, and lot of databases are there. But to find the right one, there are a lot of metrics, okay, that you will have to look on, like your data is structured or unstructured, then whether you want a key value pairs, whether you want to give asset properties or not, or whether it involves transactions or not, then scaling challenges, maintenance overhead, and total overall cost that you can actually fit your use case, right? So there are various parameters, but just to be on a safer side, what we will do is we will try to start with a SQL database, right? And SQL databases like MySQL or Postgres. So let's try to first think from a SQL database point of view inside this, and because that is the most widely used. Okay, so we will start with the SQL database schema. So for authentication service, right? For this authentication service, we will be needing various tables. So first is user table. And for this user table, we will be having certain fields, certain set of fields. So first will be ID. And of course, this will be a primary key. And since it's a primary key, it will be unique also, right? And this will be a auto increment field. And of course it will be integer. Then we will be having UUID. Many people do this, like make UUID as a primary key, but I'm not doing that here, because UUID will make sense because this will not let users know how many users are there in the databases, right? Because suppose if you expose this ID to users, so suppose let's say the user ID is 100, so he will know that already there are 100 users. But this UUID is something like character field, like ABC234 dash 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 dash. The advantage of UUID is basically to create anonymity, and with this UUID, users can actually query backend. Like suppose let's say he want to get some information about any user, so what they can do is /user ID and something, right? So just to create anonymity, this UUID is used. So all those tables which you want users to actually directly query with that, we will be using this UUID as well. But this ID makes sense because when you do joins in SQL database, right? When you make join queries, or when you have a lot of foreign keys and all that stuff. So for that kind of thing, and also indexing, this ID is more good because it's integer, direct, and it's very easy to find. It's very easy to index the ID because it's sequential, right? This UUID is like a random character, so it is difficult for that. So now next field will be like name, and here I will be using email for authentication. So you can use phone number as well, but here I am using email. Then password, of course this will be string, this will also be string, but this will also be unique, and this email will also be string, this password will be string, but it will be hashed because you will not store raw passwords in the DB. So this is a basic user table. Now we will talk about the post. Now for this functionality, we will be needing another table that is called as post. And for again, we will be using, we will be having ID field, which will also be a primary key, and this will be integer, and this will be auto increment. Also, we will be having UUID because of the same thing, because users can actually query the post by doing slash posts and then slash UUID to retrieve a specific post from the database. All right. So UUID, it will be string, or the string, or can be in some places it is mentioned as UUID field. Okay. And this will be unique. Then we will be having description. That will also be a text field, but just to mention here, we will be naming it as string. Then we will be having post images, because I want the functionality here like user can post with images, right? So for that, I can enter here image, and it will be a file field format, but here we will be storing the URL of that image, because of course when the user will upload the image, it will be stored in some extra. Of course you can store that to your server directly, but that will create an extra overhead to your server. So instead of that, what you can use is you can use some extra service that is called as S3 bucket and serve the static images from there itself. But we will talk about this static image serving later on. Let's just focus on this. So basically we will store the URL of that image in the post. But now suppose, let's say you want multiple images to be linked to a post. Suppose let's say a user can post with multiple images. So then what you can do is you can create a separate table that is called as post image. And here you can add a field ID. Of course that will be a primary key. And then we can have post ID. That will be a foreign key, and this will be linked basically to this. Okay, and of course this will be a integer, right? And then we will be having URL that will be string. Of course you can add some URL regex validators in the backend to validate the URL and all that stuff. So now basically multiple images can be linked to a single post. All right, so now we will remove this field from here, and then the user who will make the post, right? So we will have to link this user with this post. So we will add user ID here. That will also be a foreign key and integer, because we will link this with this. So that's why I have used this ID as integer field, because when you create this foreign key relationships, right, ID make more sense, because with ID you can query more faster. Okay, it improves the data fetching from database, because this ID can be indexed in a more better way. Now we have covered this post. Now we will talk about this likes and dislikes. Now this likes and dislikes can be related to your posts. So let's make a table like. So this will involve post ID. Now first of all, we will have one primary key that is called as ID. This is primary key and integer. Then we have post ID, which is a foreign key. Then we will have user ID. Okay, and we will not, if you want to have likes and dislikes both, then we will also have to mention type, like it's a like or dislike. Let's not include dislikes here right now. Let's focus only on likes. Of course you can add one type field and mention whether it's a thumb up or thumb down, but now let's remove this type field. We will look only, just to be more precise over here, I am adding only like here. So now like, but now you have to add one constraint here, because you have to make sure that one user can like one post only once, right? So you will have to add one constraint here that this together should be unique. So basically SQL database has various constraints. What you can do is you can combine these two fields and put a unique over the combination of these two fields. Okay. So this is also a foreign key. Now if I talk about comments, right? So let's make a new table. Comment. Now this will include ID, primary key, then we have text, string, this will also be integer, and then the user who has commented that, right? So user ID, foreign key, and also post ID on which user is posting, on which user is commenting. Okay, so foreign key. All right, but now you might want likes over comments as well, right? Like user can like the comment also. So that is also possible. What you can do is you can create a separate table like comment likes, and here again add comment ID and user ID and then make it unique. But you might also think that instead of creating a separate table, you can include that here itself. So to include that here itself, what you can do is you can remove another table, and what you can do is you can add here type, and type will have two options. Suppose post, comment, and then you can remove this post ID and name it as type ID. And this will not be a direct foreign key, of course. You will have to manage it through code, so it will be integer. But you will still have to, and now instead of this as unique, what you will have to do is you will have to take these three fields as a combination and add a unique constraint over these three fields together. So this is how it will be done. Now if I talk about comment, of course this is possible that user can comment and then other users can comment that comment again, right? So basically it involves a kind of a nesting structure, but here we are supporting only one level nesting. Suppose let's say this is a post, then user 1 comes and posts something, comment something here, comment, and other users can also come and comment to this comment again. So C2 and C3, we will not allow comments again like here. We will not allow this. We will only allow single nesting. Of course you can add that also, but we will focus on this right now, single nesting structure. If you go on multiple nesting, then it makes more sense to store in a unstructured fashion way, that is kind of a NoSQL databases. But right now, since we are using SQL databases, let's focus on this itself. So this kind of nesting you will be having. So here what we can do is, like, instead of this post ID, and one user can actually comment on a post multiple times also, right? So instead of having post ID, what we can do is we can use type here, and this can have types here as post or comment, and then we can have a type ID, and this will be integer. So this is a basic kind of a database schema that we have designed for it, and then there is no need for any kind of table for this user feed. We will be talking about how to design this user feed later on. Now let's focus on this notification. For this notification also, you might be storing, you may want to store this in database or not. It's your choice. That you might think that notification is not very important. You just push it to the users. So at that point of stage, there is no need to store it. But right now, just to have a basic idea, what we can do is we can add one table, and this will be having ID, primary key, integer, and then we will be having text. All right, and then we will be having basically type. It can be private, or public. And if it's a private, then we will be also mentioning here user IDs, basically to the users who we want to send this notification, because this notification can be sent to a single users also or multiple users also, which we will select. Okay, so basically what you can have is you can have user IDs and you can store that in a list format. Of course, in database you will be storing in a string format, but you will be storing like this. It will be a string, but you will basically store that. And later on, when you will parse that, you will basically try to convert into a JSON type of format and remove these quotes and try to parse this list or array. And it will be having the user IDs, basically this user ID, like suppose 2, 10, 12, etc. Alright, also if you don't want this user IDs, what you can do is you can have because a relationship between notification and user is many to many, because a single notification can be sent to multiple users and this user can receive multiple notifications also. So this will be a kind of a many to many relationship. So instead of that, what you can also do is you can have one more table, that is user notification, and then you will have user ID, notif ID. So this is also possible, but I don't think it makes sense for this notification part, so let's not do that. But you can have a many to many relationship in such a way. So let's move with this thing right now. And then we are having payments. So for payments, what we need is, for this payment we will be having one table called as orders, and it will of course have ID, primary key, integer. Then we will be having UUID, again for the same reason. And then we will be having amount. And currently I'm assuming that you are supporting only single currency, like you are not having a multiple currency system. So because if you are thinking of accepting multiple currencies from different countries, you will have to enhance the system a little bit more, but we are not covering into that. If you want the video on that, I will be making a separate dedicated video for making a robust payment system. So amount, then we will be having amount gateway, which user will actually pay using the gateway, because you will be using some kind of a payment gateway into your product, like RezervePay or Stripe, anything. Amount gateway. And then you will be having status as pending, success, failure. And then basically, of course, your payment gateway will also give a separate order ID, which it will generate. So that also you will store here. So gateway order ID. And of course, you will be having one user ID, which will be a foreign key. And in all the models, I will recommend you add two fields, that is created at and updated at. And this created at field will be populated once you create the instance in this table, and this updated at will be updated for each record when each record of this table will be updated. Okay, so you can add these two fields to every table here present here. Also, you might need one more table that is called as payment. Suppose you create the order, but now it's possible that user will pay. User can make multiple attempts to pay for this order, right? So that also you can include here, but let's not focus on that, because that is totally depending on the type of payment gateway that you are using and depending on your use case. But if you want to add that, then you can add it here, like order ID will be here, and then ID, UUID, gateway payment ID, and amount again. So this is a kind of a basic database schema that we have designed for our system. Of course, you will have to, when you actually try to implement this thing, you will have to make some changes in this as well according to your conditions. But this is our generic kind of database schema that we have designed, and this is the first thing that you should actually do also. So now we have designed this. Now what we will do is we will try to create a system architecture for these functionalities, a high level architecture to actually implement this thing. So now after doing the DB design, we have got a very clear idea of what actually has to be done and what data has to be moved here and there. So now let's try to design a system for that, like how we are actually going to implement that. Okay, so to start with, what you will do is you will basically create a repository on your local system and start coding into that, right? So suppose let's say you created one repo and you named it as XYZ backend, right? And inside that, of course, you will be having different modules to handle specific functionality. So to start with, you started with authentication. So authentication, and then you will be having one different module which will be covering post, and then likes, right? And then comments, user feed, notifications. Basically, these are different modules of your code, okay, inside a single repository. Because to start with, you can't create multiple microservices because it is very difficult to manage in starting with a very small team, and also it requires a lot of big infrastructure, which is of course costly. So notifications, and then we have payments, and all this is inside a single repository. Basically, you created a single monolith service to handle all the functionalities. Okay, simple. And then of course you will be having a database, and this will be a database, a part of a database server that you will be running on as a separate process on your local machine. Okay, this is a basically SQL server, and this is a DB. Okay, because inside a SQL server you can have multiple DBs, but since you are using a single DB for right now, so single DB. So now what will happen is basically you will code it and try to test it out locally using Postman, and you will try to hit different APIs. Now you will be moving this code to actual virtual machine, right, where you will be hosting this your code, because you can't host it on your local system, right, because you can't make it available 24/7, and also from security point of view it's not a valid point. So you will be moving this code to a cloud hosting service like AWS, Google Cloud, or you can also deploy a sharing hosting platform. But I will suggest to use DigitalOcean, AWS, or these kind of things, because you have more control over that. And if you are thinking for a long term perspective, you can go ahead with this. It will cost in starting not very much, because of course you will be having a very little traffic. So, and of course the code base will also be small, and you will not be using multiple services of that. So you move all this code to AWS. Suppose let's say I'm using AWS. Okay, so you will move this XYZ backend code to AWS instance. So now I am using this AWS EC2. I will basically push this code to GitHub and clone the repository there. And now to start that server, basically what you have to do is you want this process to keep on running in background, because when you start this locally, what you do is you start in a development server, then start it and then press Ctrl+C and it automatically shuts down. But you want this to run in background, right? So you will need a web server for that. And for DB also you will have to move to a different kind of service. One way is you can create this DB server on this AWS instance also. Like here you can create this, you can basically start this DB server here itself, but I will not recommend that because you should keep your code base and this data separate. So I will recommend to use a separate server, or what you can do is you can use the services like AWS provide AWS RDS. So now instead of this SQL server, I will use AWS RDS service, and I will be having a DB over there, and this code base will be linked to this DB. Now basically what will happen is you will basically deploy this application, right, using a web server. Now what is this web server? Web server is like basically you will tell your web server to bind your application to a specific port. And what you actually mean by this is you will tell this web server like start listening to traffic from outside at port number 8000, suppose, let's say at port number 8000, and whatever requests are coming on this port, forward those requests to this backend. Okay. So this is how this web server will communicate with this code base and to our clients. And this web server is specific to a language usually. Like for Python, you have different options like GUnicorn and Daphne, Uvicorn, and Node.js has its own inbuilt web server. Then also Go also has its inbuilt web server. So it depends on the language that you choose for designing this code base. Now web server has started listening to this 8000 port. So whatever request will come over this 8000 port, it will forward those requests to this code base. Also you can, like, instead of this 8000 port, you can directly use 80 port itself, so that all your traffic is directly forwarded to 80 port, because people generally make HTTP requests, right? I'm not going much deeper into this HTTP and all that stuff because I will try to make a separate video for that, like networking basically. So suppose let's say you bind your application on 80 port. So this web server will start listening to this 80 port, and all your users can directly make a request. Like suppose users can make a request from their mobile phones, or they can make a request from desktops, all right, like from their laptops and from their Chrome browser. So all these requests will go to this web server and then will be forwarded to this code base. They will process the request, query the database, get the right data, and will give it back to the users. So this is the basic flow. Now if I talk about authentication, okay, so what will happen is basically user will hit the endpoint. Suppose let's say user hit the endpoint, and of course to make this code base available to the public, what you will have to do is you will have to use DNS servers. Okay, now this DNS server can be of anyone, of this AWS also or GoDaddy also, the place from where you have purchased the domain. All right, you must have purchased some domain, right? Suppose let's say the domain that I have purchased is xyz.com from GoDaddy, and suppose let's say you are using the GoDaddy DNS servers. So what this DNS server will do is you will go there to the GoDaddy website in your account, and AWS EC2 instance will all have some IP address, the public IP address. Suppose let's say it's 72.32.2.112, something like this. Okay, so what you will do is you will point this IP address, and this DNS server, what it will do is it will hold a table kind of structure, and it will have fields like IP and then domain. You will mention here the IP address is this, and point this IP address or point this domain to this IP address. Okay, so what will happen is whenever user wants to access your application through this domain like www.xyz.com, what they will do is first they will hit this DNS server, and this DNS server is hosted by GoDaddy or AWS in different zones so that it's easily accessible. So they will reach here, then DNS server will tell them, okay, this domain is pointed towards this IP address, so it will return back the IP address. And now this browser will make a direct request to the server using this IP address. So suppose, let's say you made a request at HTTP, and I'm not talking about HTTPS right now because you have not configured yet till now. So HTTP www.xyz.com, and suppose you have made an endpoint called as login. All right, now it's a post request because you will be providing certain credentials here. Suppose, let's say in request body you will be passing email, and email can be anything, and your password. And this web server will forward that request to this authentication module. First, what it will do is it will query the database, like select star from DB where email equals to the email that you have got from request body. So this thing. So this DB will find out that if actually that record exists or not in DB. If it's there, then it will return back. It will return back to this authentication service. And once it is returned to authentication service, then it will check the password, okay? Because of course it will be giving the full user record. So since that password was hashed, right? It was hashed. This authentication service will hash this password again. It will create the hash of this because this password cannot be unhashed again, or maybe you are using some different encryption algorithm through which it can be again decrypted. But now I am using in such a way that it cannot be decrypted again. So now you will create the hash of this, and then you will compare this password and this password, this hashed password, and if they are equal, then this authentication service will say, okay, you are granted the access, and this authentication service will return this to web server and then to user. Basically, it will return, and here I am using a JWT token authentication mechanism because now most of people are using that only. Basically, JWT token authentication. So what it will do basically is it will create a payload first of all, and this payload will contain some user information. Okay, so suppose let's say it contains UUID of that user, and it is something. And I think you can add some more information here also, but for now I am just using this UUID. So now what it will do is it will create the hash of this full payload, and it will sign that in hash. Basically, suppose let's say there is a function create hash where you will pass this payload, and it will give something, suppose X, and then you will use this X to sign this. Okay. So basically in this code, you also have something called as private key. Okay, this private key you will use to sign this hash. So now there's function called as sign where you will pass this X and private key, and this will give you access token, or you can say JWT token, and you will return this as a response to this user. Now user can use this token and place this in the headers of the request to access the private endpoints. Suppose he wants to post that. So how will the backend will identify which user is wanting to post? So that will happen using this token. So what will happen is basically, suppose this user wants to post something, so it will hit the endpoint now, but now it will be not login, it will be post, and it will pass certain details here, like basically description and then image, okay, and this will also be a post request, and with this request, he will also attach in the header information this token in authorization field. Authorization and this token which he has got from here. Okay, this token. So then what this backend will do is this web server will forward this request to backend, and backend will say that this responsibility of this is yours, post. And this post, what it will do is it will decrypt this token. So first of all, for decryption there will be another thing that is called as public key, which is also be stored in this authentication service. And for decryption, it will use this public key. There will be some function called as decrypt, which will take input of this token which user has passed in headers and this public key. A decryption will only happen if this token is valid. Of course, this token will be having some extra information also, like basically it will also have some extra information called as expiry timestamp, which you can customize, and in seconds it will be having that. And this function will be able to decrypt this token only if it is a valid one, like if it was actually signed using this private key. Alright, first of all that, and second is it's not expired. Okay, this expiry timestamp is basically this timestamp is still lower than the current time, so only then it will say that okay, it's a valid request. Now this post service, what it will do is it will take this details, basically it will perform some kind of validation over these fields, and if it's valid, then it will create a record inside this DB. And also one more thing, this DNS server is not aware of the port that we have here. So basically when you try to access any server using HTTP request, the default port of that is 80 port only. So by default it will try to access through 80 port. This web server will resolve that automatically. Now if I talk about this notification service, right? So this notification service is, so HTTP request is a kind of a one-way communication. Like your user will request something, it will process the request and it will give the response back to the user. So it's a kind of a one-way communication. Only when the user wants a response from the backend, only then it will be done. But this notification is kind of a different thing. Notification means the server has to send something to this user on its own. So basically it's a kind of a two-way communication. Suppose let's say you are user 1 and this is user 2 and you follow this user. Okay, now this user 2 makes some post. Now you want some notification to be sent automatically by the server, right? So it's a kind of a two-way communication which is not possible using HTTP. So now to enable that feature, you will have to upgrade from HTTP to WebSocket. Okay, now to have that thing, first of all the code that you have designed, it should be able to handle WebSocket connections. So basically when you will run this process, right, this is a complete single process which will be running on this machine, this virtual machine. So if your code base supports that thing, and also your web server should support the WebSocket thing, because users will make connection to this web server first, right? So this web server should be able to handle these WebSocket requests also. You can have notification service inside a single process and keep it running. That is fine, totally fine. But most of the time, your code base or this web server does not support this WebSockets. So what you can do is you can use this web server. If your web server do not support that, but your code base supports that. So this is web server 1 for HTTP, and you can use one more web server which support WebSocket, and also it will route the information here. But since it's a WebSocket, of course your code base will handle that this part will be handled by this service which is dedicated for that. So now what will happen is user will try to make a connection with our system, right? User will try to make a connection. Now it will try to make a WebSocket connection using this endpoint that is called as WebSocket xyz.com. The port of WebSocket is same as that of HTTP. So again, it will try to connect to the 80 port. But now, how will this thing, user will know to which web server I have to connect to? Because there are two options. He doesn't know about what all these things are happening. He is not aware about that. So now you will have to add one extra thing that is called as reverse proxy. So now we will add one more module, which is called as reverse proxy, and here for this example we are using Nginx for this. Okay, Nginx we will use here, which will act as a reverse proxy. So what it will do is, user will hit this Nginx, and suppose let's say this web server, you have binded this web server to listen on 8000 port, and this web server to 8080 port. Okay, I'm just taking the example. So now this reverse proxy, what it will do is, if the request is coming from WebSocket, then it will route the traffic to this web server, and if it coming for HTTP, then it will route the traffic to this web server, and automatically web servers will handle these things. And the advantage of this Nginx, this Nginx can be used for more things, like for reverse proxy, and inside this reverse proxy you can also handle SSL certificate also. Like regarding this, beside this traffic routing, you can also add, you also had some more advantages over this reverse proxy Nginx. Basically you can add SSL certificate. So now you can specify the SSL information inside this Nginx. Basically you can use let's encrypt to create a free SSL certificate and mention about the details inside this reverse proxy configuration, and then your user can actually upgrade from this WebSocket to WebSocket secure and HTTP to HTTPS, and this is totally free. So only thing that you have to pay right now is for AWS EC2 and for this RDA server. You can also remove this by deploying this DB server by your own inside this AWS EC2, or you can use another AWS EC2 for this DB thing and make a connection between these two instances. And now what you can do is, I will recommend to shift this notification service from here. Of course you can write the code inside this repo itself, but you will run that notification service as a separate process here, as a separate process, and this web server will route traffic from here to this notification service. And this notification service, what it will do is, basically it will store the information of user, like from this IP address connection has been made, because when it will make a WebSocket connection, some information has to be stored corresponding to that IP address, so that server wants to send some notification to that user, they can find that details from this through this IP address. And also they will be, and if you want to send it to a particular user, you will also be storing something called as user ID, user UUID basically, okay, to identify that specific user. Like from this IP address, this user has made the connection, and this is the WebSocket connection details, so that you can find that specific user and send the notification to that user specifically. Otherwise, if it's a public notification connection, then you can remove this thing, and basically suppose let's say user is not authenticated, right? So of course he will not be able to pass that token. So, and for WebSocket, I think request header doesn't work like this. So what you can do is, you can pass that token as a query string parameter here. And now since it's WSS, so it will be secure only. Okay. So using this token, this notification service will identify that this user has, and this notification service is also linked to this DB. Okay. With this token, it will identify with which user is trying to make a connection, and it will store the information accordingly. If this token is not there, then it will be a public WebSocket connection, and it will only forward the notification to that user which are publicly sent. Some kind of promotion notification that sale is live or something like that, or some basically public notifications. If the server wants to send, then they can send using this public WebSocket connection. Now we will be talking about how to scale this notification service later on. First of all, let's just think. Let's just enhance the system a more little bit. Okay. So now we have talked about this authentication service, post service. Likes and comments are simple only. Now let's talk about this user feed service. Okay. How this user feed service will work. Now for user feed, what user will do is, it will hit the endpoint https xyz.com/userfeed. Okay, and it will pass its JWT token after login with the headers of this request. Now it will be a GET request. Okay. So now it will go to Nginx. It will see that it's from HTTPS. It will route the traffic to this web server 1, and this web server 1 will forward this to this code base, and this code base will automatically see that it's the responsibility of this Userfeed module. Now this Userfeed, what it will do is, first of all, basically first DB query will be made like this: select star from users, because first of all it will make a normal authentication check. Select star from users where UUID equals to basically that token that will be decrypted, right? From that UUID will be taken out because we have stored that information inside that token. So it will pass this. If it is there, then it will say okay, user is authenticated. And now the second step will be to give back the user feed. First, user feed service will have to find out whom does this user follow. And also we have forgot one more service here, that is basically follow service here, right? And this follow service will be having fields like follower ID, follow ID, basically the person who this follower follows, and of course ID, primary key, and this will be a foreign key, and this is a foreign key, and this will be unique, because one user can follow one person only once, right? So this is a kind of a database schema for this table. So now another query will be made: select star from follow where follower ID equals to this UUID, and this will give back all the users who this user follows. And once we have got that, third query will be made. So basically you will get that data and store the user IDs in a array format. Suppose let's say he follows 2, 3, 4, 5. These are the primary key, that is ID, and as I told you, this will be helpful in querying the database. This will make the DB queries more fast instead of querying through UUID. So now third part, select star from posts where user ID in this array. So 2, 3, 4, 5, and this will give all the posts, but of course there will be so many posts, so you can't give that in a single go. What you will do is you will basically use some sort of pagination here. So let's use some pagination here, and also you will be sorting that using created at field. So order by created at, and we'll be sorting that in reverse fashion, because when you generally open the user feed, you will get the recent post at the top, and then you scroll down, it will give you older posts. So order by created at DESC in descending order, and then you will be having some limit here. Suppose let's say I'm having a limit of 20 here. So in single go I will be giving only 20 posts. Then user will scroll down, and when he will reach the end, then front end will again make a request to the back end. That's I want the user feed. But now since we have used some sort of pagination, he will also the front end will also send a page number in the query string parameter. So page equals to 2. Or if we do not want to use this page number pagination because it's not actually good, you can use a limit offset pagination. So what you can do is you can use a field here. So of course, let's say you have got from in the first hit, you have got the post from 1 to 20, and all these posts were like ordered sequentially, ordered using the ID in this post table. So like 1, 2, 3, 4, then 20, and you have given the last 20, right? So basically, suppose let's say you have given this in the first hit. All right, because they are numbered in the sequential fashion and you have given the last one. But in the meantime, when the user hit this endpoint for the second time, right, you want the older post after that. You want the older post like below this thing. But it's also possible that in the meantime, the people you follow have also posted in between. Like some posts are there like 41, 42, 43. How will you identify what post you have to give back? So what you can do is you can pass one more field in the query string parameter, that basically timestamp. So when you have got these 20 posts in a single first go, you have got created at field also with this. So suppose let's say the created at field of this thing was something. So what you want is basically this x timestamp will be passed inside this as a query string parameter, and this user feed service, what it will do is it will query the post limit to NT, but it will also add one more condition where user ID in this and created at is less than x. So this will basically give all the posts which are before this thing, and again it will sort it in the reverse fashion because we have used this order by. So this is how user feed service will work. And this is a very naive approach of designing the user feed service. And of course, like if you close the app and open it again, then it will again fetch the same user feed. So it will again go through all this process, right? So it's a big process there. But now since you are using a single monolith service, it makes sense, right? This is not an actual overhead. This is normal thing. So this will work perfectly fine. And also you will be having certain static data like inside this repo which you have directly put it over there, like static images and all that stuff, right? Static data, which instead of serving by your web server directly, what you can do is you can tell this Nginx server, because this Nginx server can also be used for serving static data, okay, on your server, because this web server role is not to handle that static data. Its only role is to handle dynamic content. To serve the static data, what you can tell this Nginx is that all my static files are located in this specific directory. You can specify that directory. So in case, because all these posts will have the URL thing, right? Or maybe you are storing that images in some external storage. Suppose let's say AWS provides S3 bucket and DigitalOcean provides spaces. So you can store those images there and store the URL of those fields inside the database, because this will serve as a CDN. These basically this S3 bucket will be hosted on different zones. So whatever it's closest to user, the image will be served from there directly. But there will be some images like logo and all that stuff will be there on your server. So instead of relying on this web server, what you can say is you can serve that static data instead from this web server. You can use this Nginx by mentioning that directory here. So whenever user will request for that logo image and all that stuff, it will be served directly from Nginx directly. Call will be made to this static data and it will be retrieved and sent to this. This will reduce an extra overhead on your main application. So now we have talked about this notification service also, and user feed also is little bit done. A basic naive approach is done. But of course, when we will scale this service and divide this big monolith service into multiple microservices, we will be scaling this user feed to a much advanced level. The thing that is left is payment service. Let's talk about this a little bit more. So now all these things are running on this single AWS virtual machine, right? Like this Nginx also, server also, this application also, which you are running manually each by each. Like you have to run this separately, this separately, this separately, this separately, this separately. So you have to do a lot of manual work. So now let's talk about this payment thing. So now suppose let's say you are using some kind of a third-party payment gateway like Stripe or Razorpay. So they will be having their servers separately. Suppose let's say this is Stripe or Razorpay. All right. So now suppose let's say this user made a payment. So before making a payment, first you will have to create an order instance in your DB. So this will first hit this endpoint here xyz.com/orders, and it will specify certain more details here in request body, what all this order is for and all that stuff. And basically what you will do is this Nginx will forward this to web server 1 and this forward to payments thing. And payments thing, what it will do is it will hit the endpoint of this Stripe or Razorpay, get the response, because order will also be created inside this third party service, which will basically give you back order ID, and this will be served as a gateway order ID for your system. And also you will generate your own order ID for the user, and you will basically return all this information together to the user. Inside the request body you will pass various parameters like gateway, order ID, and various other details, right? Now let's rub this first. Now after you have received this gateway order ID, user can proceed for the payment, and our payment gateway will be open here, because like of Razorpay it opens like this. User will enter the card details or UPI anything, and then it will directly hit this Stripe or Razorpay, because your front end will specify the gateway order ID. And so this gateway order ID, this Razorpay will identify that okay, from for this order this payment is basically coming. So now once this request is hit to Razorpay, Razorpay will have a connections to the banks and all that stuff, which it will care of. And after Razorpay has basically received the payment, actually what it will do is it has a thing called as webhook, but you can create this in a multiple ways, but I'm just taking an example here. Basically you will have a webhook service here in Razorpay, where you will specify the URL of your service, which Razorpay will hit after it has received the payments. So suppose let's say you have thing like you have a URL on your system, basically xyz.com/webhook, which you can name anything, and payment. So now this Razorpay will hit this endpoint. This will again go to this Nginx, this web server. This will go to this payment thing, and this payment will check that first it will validate the request that it's actually coming from Razorpay or not through some signature mechanism and all that stuff. And this payments, what it will do is, after identifying the order, because this Razorpay will also specify the gateway order ID, and we have stored that gateway order ID in the orders table, so we will identify that order, and then accordingly what we will do is we will again hit this Razorpay to capture the payment. Capture payment. And once captured, then the payment is actually processed in Razorpay. Okay, if it's not captured after some time of after some duration, it gets reverted back to the user if it's not captured in some specific duration that you will specify on the Razorpay dashboard. So after you have captured, then it actually means that things have done. Once you have got the success response from Razorpay after you have hit the endpoint, then you can mark the order as success. But still this payment thing has a lot of edge cases which you might miss, because it involves a lot of HTTP calls, right? Because this it is hitting our endpoint, and then we are again hitting capture payment. What if this HTTP request fails in between? Maybe suppose let's say Razorpay has authorized, like it has received the payment, but it is trying to hit our service, but our service is down, so it will not be able to receive that request. Or suppose we are hitting this capture payment endpoint of this Razorpay, and this capture payment actually hits here. It successfully executes. Okay, we have successfully captured, but then Razorpay goes down and it fails to give the response back. So we will not get to know actually that the payment has actually been captured or not. We will think that it is not still captured, but all the operations have been executed here. So we can't trust on these HTTP calls. And here comes the concept of background workers or reconciliation scripts. And that is the sole reason why I have included the payments inside this, because here you need a lot of reconciliations and background workers to actually monitor this type of stuff. So now let's talk about that. So now suppose let's say your payment is under pending state, your order is under pending state. You have hit this endpoint, capture payments, but you have not got a success response from here. So you will not directly mark it as failure here. You cannot do that because you can't trust the HTTP call. What you will do is you will write some code inside this repo itself or outside this repo. That is your wish. So suppose let's say you have some background workers here, but you have written the code here, but you will run these background workers separately, not here, because this will be of no use then. All the overload will come on your application itself. But you want these operations to be performed in background, right? That's why the name is background worker. So right now you can run these background workers on this virtual machine itself, but as a separate process. So suppose let's say I'm running this here. These are background workers. Also one more process will run here inside this virtual machine itself, basically where you will schedule the task. So task scheduling will happen here. So you will tell that every half an hour run this specific task which will perform some operations. So of course you can run a cron job also, which might be good option in some scenarios, but I'm talking about background workers right now. So what this will do is this will keep on looking into that. Basically this task scheduling, the schedules can be stored in a file or in database also. That's your choice. So suppose let's say all these, like you can mention that this task will execute at this point of time after this interval. So you can store this information in DB. So this service, what it will do is it will keep on querying this DB after frequently and see that if any task has to be executed or not. If it finds that, then what it will do is it will push this to be executed by these background workers. But that does not happen directly, because earlier users were trying to communicate to our server using the HTTP calls. But now what we will do is we will use something called as queue or message brokers. So this is also a thing inside your virtual machine. Basically you will use message brokers. And suppose let's say I'm using RabbitMQ here. RabbitMQ or Kafka you can use as a message broker, which are two good options. So now I'm talking about RabbitMQ here. So this is one queue. So this RabbitMQ server will be also running on your system, which you will run manually as a separate process. So this is a RabbitMQ server which you will be running on this virtual machine, and this is a one queue of your RabbitMQ server. It can have multiple queues also, but right now for this specific thing we have created one queue which will basically push this task to this queue. And this queue is like first in first out FIFO mechanism it follows. So suppose let's say T1, T2, T3. These are pushed to the queue in sequential fashion. First T1, then T2, then T3, and then so on. And these are background workers. This background worker will basically have a consumer here. And this has a producer which will produce the task to this queue. And this consumer will consume the task from here and run this task on this separate process. Okay, so basically what will happen is you will not mark this order as failure directly here. This background worker will every half an hour it will execute one task that what it will do is it will query this Razorpay and get order status by mentioning the order ID. So it will pass the gateway order ID in query string parameter and get the order details. So if it says it's captured, right? If it's captured, only then it will mark it as success. And if it says that it's failed or something, then it will mark it as to failure. And if it says that it's not captured, it's still we have received the payment but you have not captured, then it will try to capture that request. So this is how the reconciliation works and using the message brokers. So we have now talked about message brokers also, notification service also. So all these things are running right now on a single virtual machine. We have a single DB. So what you can do is one thing you can do is you can increase the, like suppose let's say you are getting now enough traffic, your system is getting overload, what you can do is you can do vertical scaling. You can increase the resources of this machine by increasing the RAM, storage, and basically the GPU and all that stuff you can increase of the system. Of course, vertical scaling has one point after which it cannot be scaled. So then comes the role of horizontal scaling, and also we can divide this big monolith service into small parts, and that is what we will be covering next. So last thing that we were talking about was about this background workers that was basically performing a task for payment reconciliation. So basically in this scheduler we have specified the task to basically which will run automatically after every half an hour, and this task scheduler will push that task every half an hour to this queue, and from this queue this background worker will consume that task, and this background worker will perform that payment reconciliation task, which is nothing but it will directly query this DB and get all the orders which are in pending state, and then hit third-party API of Razorpay to check the status of that order, if it's paid or not by the user. So since it involves payments and lot of stuff is happening over here, we will have to look more deep into this because it involves a lot of edge cases which we will have to take care of before actually making it available to audience. Okay, so basically what is happening here is this queue basically pushes the task or message which is received on this in a FIFO manner to this background worker, which will be having a consumer to consume the task, right? So what happens is when this queue pushes the message to this background worker has to send the acknowledgement to this queue that okay, I have received the message. Now you can remove this thing from the queue. First this queue will send a task to this background worker, and then this background worker will basically send an acknowledgement. Okay, now you can remove this task. Okay, so now this acknowledgement sending can be happening in two ways. First is in starting itself, like suppose this consumer has received the task, it has not even processed or worked upon the task, and before only it has sent the acknowledgement, and then only this queue has removed the task. Or other cases, first background receives the task, it executes the full task, like make this query, then hit this Razorpay and all that stuff it performs, and then put the acknowledgement. So it can happen in two ways. So now you have to decide whether you want to acknowledge the task or message in starting or after the execution of the task. So let's try to figure out what it will be here. So first of all, suppose let's say this task is acknowledged by background worker in starting itself. Okay, so suppose let's say this background worker acknowledges this task in starting itself, and after acknowledgement it starts executing that task. Now it's possible that that task execution gets failed due to some reason, like because of system failure or due to some unexpected error. So then that task will be failed, and since that task is removed from the queue, the task will never happen again, of course, because this queue has already removed the task. But since this task is repetitive and this task scheduler will again send this task after half an hour, so it can again query the DB and get the same record, because it will be left in pending state, of course, because it was not processed fully. So it will again get the task, it will again query the DB, and it will receive the same records and start executing them. So it's fine here, right? And first of all, if you are performing multiple operations here inside this task, you might be using something called as transactions, which SQL DB provides you, basically the asset properties. So transaction is nothing but you will be performing multiple DB operations inside a transaction block, which guarantees you that either all the tasks execute, like all the operations will be performed over the DB, or nothing will be performed. If suppose let's say first, second executes successfully, and before this third operation is executed, server fails, these two operations will roll back to the original state. Basically this is called as atomicity. Okay, so this is the role of transactions. Now suppose let's say you are acknowledging it in starting itself, and then using the transaction block you are performing certain operations. All right, fine, cool. But now there is one more case. Suppose let's say you have acknowledged this in starting itself, but now this background worker, this time is taking a lot of time. Okay, it's still performing the task 1, but and already half an hour has already occurred. Okay, now this queue is forcing this T2 to be consumed by this background worker. So suppose let's say there are 2 background workers running. So instead of 1, we have to increase the concurrency. We have increased 2 workers, basically 2 processes of this background worker behind the scenes. Now this first worker is performing still the T1, and now this second worker has consumed this task 2, and still this background worker 1 is performing the task. There might be some records here which are still in pending state, for which status has not been updated by this worker 1. So this second worker will again query this DB to get the pending orders. So it's possible that the second worker has retrieved the same records on which this first background worker is performing the operations, right? Suppose let's say it has retrieved second, third, fourth. Okay, and this second worker has also queried this DB and also got this 2, 3, 4 from this DB. Now suppose let's say now this background worker is performing the operations for the second record. It hit this Razorpay API, got the success response that it has already been paid. So now after it has been marked as success, there are certain 2, 3 operations which executes only after you are sure that this second order was paid successfully. So suppose let's say there are 2, 3 operations here which actually creates a new record in database, maybe some different tables, okay, affecting the different tables. So first basically this second record will be marked as success, and this record is already there in local memory, okay, and since you are using a transaction block, it will only, this success thing will only be reflected in the DB only after all these full set of operations have been performed, okay. So now this, according to this second worker, this second thing, the second record is still in pending state, although in locally it has been marked as success, but since more steps have to be executed, according to this worker, when it has retrieved the record from DB, it was still in pending state. So what it will do is, it will again hit the Razorpay, got the success response, and again it will try to execute these 3 operations. Suppose let's say 3 operations have to be performed after it has been marked as success. So this will result in execution of these records, execution of these steps 2 times, and you might end up creating these same records twice in the DB, which will lead to inconsistency in the database, which we do not want. So basically we want to make our task idempotent. Idempotent means how many times you execute the task, it will result in the same thing, or it might not lead to inconsistencies in the data that is stored actually in the source of truth. And source of truth here is DB, our database. So to make this task idempotent, what we can do is, first of all, like when you are querying this, when you are retrieving those records, what you can do is you can use database logs. Okay, you can use this database logs so that if this background worker has retrieved those records, if the second worker tries to retrieve the same records, you will give the error response. This database will give the error response that these rows are already logged, so you can't retrieve those records. Okay, so basically these database logs can be of different types. First is basically like it will raise error if you try to retrieve the same records. Second is, that is immediately basically. Second is it will wait. It will wait for the records to be released by the first thing that has basically logged the rows. Okay, suppose let's say this background worker 1 has used the second type of lock here. So second worker will wait for the rows to be released by this background worker. But this will result in excessive usage of time, and since this task is repetitive, we don't want this type of thing. Other thing that is here is basically skip. So when worker 2 will try to retrieve the pending rows, this DB will return only those rows which are not logged by other process. Okay, so it will not give these 3 records. It will return the other pending records in the database. So you can use this or this Okay, but it's totally your choice what you want to choose here. So your task should always be to create idempotent tasks, and it's possible that there might be a case where creating an idempotent task is not possible. Then you will have to handle that situation and create the system according to that. But now let's focus on this thing. So I think this is clear now, okay, that we will acknowledge the thing in starting itself, because this is a repetitive task, so there is no need of acknowledging it later on. Even if it fails, then of course it will be this scheduler will again send the task, and this will again retrieve the rows which are still in pending state. So that is not the issue. And second thing is, we will use the database logs so that this kind of thing, this data inconsistency does not happen. Now there can be some other cases also where the task is not repetitive. Okay, you suppose, let's say you have performed some operation here, and now you don't want to perform the task here because you don't want to create an extra overhead over the main core application. What you do is you push that task to this queue, and this queue task will be consumed by this background worker, and this background worker will perform the task in the background. Now suppose, let's say the task is very critical. Okay, the task is very critical which you have to perform, and first of all it's not repetitive. Okay, so critical, so you will have to make sure that task is executed by this background worker successfully. You have to make sure that, okay, and also you have to, and since it's not repetitive, you cannot acknowledge it in starting itself. This is not possible here, because if you acknowledge in starting and due to some reason, because of system failure or anything, your system goes down, so this task will be left in between and this system will be down, and of course your queue would have removed the task before itself. So this task is gone completely. It will never be executed, which you don't want to do. So for this critical task, what you will do is you will acknowledge this task later on. Okay, you will use acknowledgement after it has been executed. So now since you are acknowledging it after it has been executed, so it makes more sense here. But now what happens is, when this queue pushes that task to a consumer, basically what happens is it waits for X seconds or minutes duration that the consumer will send me the acknowledgement so that I can remove that task from the queue. But now suppose, let's say your task is taking a lot of time. Okay, your task is taking a lot of time and it has crossed this X duration. Now what your queue will do is it will try to push that task again to the available workers. Suppose, let's say worker 1 is executing that task and it's taking a lot of time. So it has crossed this X duration. Now this queue will push this task again to worker 2. After it has pushed this task to worker 2, and worker 2 will try to perform the same operations now. But now your task is not idempotent also. So if it is picked by 2 workers, it might lead to certain inconsistencies. In this case also, what you can do is you can use database logs. Okay, you can use this DB log. So even if this is picked up by the second worker will see that this row is already logged, so I will not perform the operation. So here also DB logs will be useful here. And also it is possible that this worker 1 will continue, like because of some reason it is stuck somewhere and it is taking infinite time to complete the task. So in that case, what you can do is this database log, you can set an expiry over here. You can set an expiry over here because you have to make sure that task is executed. But now the task is taking too lot of time, which you don't want. So you have put a expiry over this database log. So suppose, let's say after Y duration, this log will be expired. So this worker 1 will break, of course, in between. Okay, it will break and this log will be released. So this queue, of course, because this task is not removed yet from this queue, it will again try to make that task consumed by the worker. So now it will be again consumed by some worker which is available, and that task can now perform operations because now this log has been released. So now it can actually perform that task. So in this way we can be sure and make sure that this task is executed in successful fashion. So this is something what I wanted to cover about. about idempotent task and acknowledgement, and you basically have to think about every edge case possible, because this is a critical step when we handle with the payments. So in payments, usually we have to think from, we basically have to include transactions, database logs, and reconciliation scripts. So to make it more synchronized and consistent. Now we will talk about this notification in much more depth now. Okay, like because this notification can happen in two cases. First of all, if the person you follow makes any post, then you should get a notification. And second is, suppose let's say someone likes your post or comments on your post, then also you might need notifications. So we will talk about that now. And also one thing, keep in mind, whenever you are hitting a third-party API or making any web request from your backend, then use a request timeout, so that suppose let's say you are making a web request, then if it's taking a lot of time and you have set a duration of 2 minutes, it will stop at that point of time, so that you can continue the remaining task of that process, instead of just waiting for that request which is taking a lot of time. So now let's talk about this notification part. And the thing that we discussed earlier was that this notification was running as a separate process inside a single virtual machine. It is running as a separate process. If you are running this here itself, on this itself, then if someone makes a post, right? If someone makes a HTTP request and hits the endpoint to make a post, then this post functionality will basically take care of that. And after that, what it will do is, after the user makes the post, it will tell the notification thing, send the notification to the user. And since user has made a WebSocket connection with the server, you have the details. If it's there, then you will send the notification to these users, right? And here we want to store notification in database also. So what we will do is we will try to make that here. And as you must have remembered, we have made a DB design for notification like this. Like there is a notif table which will have ID, text, user IDs basically. But I think this doesn't make any sense, because when the user will query the DB, then it will be difficult for querying the user specific notifications here, because we will be storing that user IDs here. So instead of that, what we can do is we can make another table to have a many-to-many relationship. So user notification, and here we will be having notif ID and user ID. So when the user will request for notifications, like slash notifications, so we can query this user notification. We can make a join over this notification and user notification table, and we can retrieve only selective notifications which are specific to that user. Like select star from notifications, join user notification on notif.id equals to user notif.id dot notif ID, where user ID equals to the requesting user basically. So user ID. But now to send this notification, how it will fully work, let's talk about that. So first, this user hits this endpoint at /post and provide all the details. Now what this post will do is, and now we are considering that notification is running inside this process itself, so it can directly communicate through the code itself, and this is linked to DB, full thing is linked to DB. So this notification part can also talk to DB directly. So what this notification will do is, first of all, it will have some function here like send notification, which will accept some payload, the data that has to be sent to the user, and also it will receive user ID list, which is an array. So what this post thing will do is, it will first of all make a DB query, select star from follow table, where followee ID equals to the person who is hitting this post request, who is hitting this and this post endpoint. So this user ID, this is the first step. And then what it will do is, it will call this function send notification and provide the payload, and pass the list of the user IDs retrieved from here, from the first part. Now this notification part, what it will do is it will check whoever has made the WebSocket connection with the server, and also present here, it will try to send notification to them. And this notification first of all will create the database records here inside the DB. So next step will be DB records, record creation for notification, and then actually sending the notification. And now this notification can also involve two kinds of notifications. First is basically bell notification that you see on your web application or mobile application. You see the bell icon at the top in the nav bar, right, usually. So in the kind of that. And second is a kind of push notification, which you generally receive on your mobile phones or your browsers, even when you have not opened their applications on your phone, or because this push notification use something called as service workers, which will always keep on running behind the scenes in your phones. And for this push notification, you generally use Firebase, because Firebase provides that service. So what you can do is you can use Firebase push notification service to send these kind of notifications, because these are out of scope of your applications, because you cannot send this push notifications through the WebSocket connections that user has made with your app. Because once the user closes your application, that WebSocket connection will be broken. But this push notification will not work like that. It will use your service workers, which will keep on running behind the scenes. So this notification will send a notification in two kinds of formats. One is bell notification and push notification, which is your choice if you want to send or not. But now suppose, let's say you are not running this notification thing here. Okay, you are not running inside the same process. What you have done is you have created a separate repo or a part of this repo, but you are running it as a separate process. So now this posts functionality of this post module of your code cannot directly communicate with this notification part. So we will have to find some way of communication between these two. One way is through HTTP calls, right? What you can do is you can create an endpoint inside this notification part and receive parameters inside that, which will be a post request, which will receive payload and user IDs and send the notification to these people. And of course, this notification still can contact to this DB directly, because of course for authentication part, because when the user will be making a private WebSocket connection with this notification part, then first of all, to authenticate that user, what this notification service will have to do is it will try to decrypt that token. And after it has decrypted the token, it has got suppose UUID. So when this post will hit this endpoint, it will send the list of UUIDs of those users, so that notification service can send the notification to those specific users. And right now, since we are storing these notifications in DB and we want to store in the same DB, of course for authentication part there is no need for this DB also, because we are using a JWT token authentication mechanism, through which only through decrypting that token, only thing that is needed here is public key, which was common here also. Here also it was there, and here also it was there, so that this notification service can authenticate that user. So now this is done, and this notification part will actually create the rows in the DB, in the same DB. So this is how it all will happen. But now suppose, let's say the user who is making the post has lot of followers. Okay, it has lot of followers. If it's 5-6, then it will be easy and it will be done in very quickly also. And if anyone likes or comments on your post, then also it will be very simple, because the notification will be sent only to you. But in case there are a lot of followers, then how will you handle that case? And also, like in notification part, because since we are having multiple type of notifications, like for likes and comment, you can also add one more field called as type, and you can mention there whether it's a new post notification, or it's a like, or it's a comment. And if you want to add some custom data with that and you are not sure whether you have to create a new field for that specific thing inside the table or not, what you can do is you can store an extra field here, extras, and inside this extras you can add some custom data which you are not sure, and after some time you are sure that this field can be included in the table, then you can make a separate field with that. But now suppose, let's say in starting you don't know, so you can store in extras field. Basically you will store in string format only, but you will store that inside the string some JSON format which will have a key and value. So it will be easier to parse those things when you are switching from one type of notification to other. Now if we talk about this, how will we handle that case if there are a lot of followers? So for sending notification to them, what we can do is use some sort of batching. When this notification part will receive the thing that when basically through HTTP call, okay, when it will receive that, okay, this notification has to be sent to this huge list of users. It can select only first 10 or suppose let's say 100 users, send the notification, and after some duration of time then again picks up 100. And before we talk about this, let's talk about another way through which this post service can actually communicate with this notification part. Second is basically using queue. This user has created a post, so now this post thing can actually send, instead of directly communicating with this notification service, what it can do is it can send that task to this queue, or what we can do is we can create a separate queue for this specific thing. We can create one more queue which is specifically for notifications, and this will basically send the task to this queue, and this notification will have a consumer which will listen to this queue, and this task will have a payload, basically the notification part that has to be sent, and also the details of the user IDs. So this is how the second way will work, and the second way makes more sense because this is more dependable instead of HTTP web requests. So now suppose, let's say now there are a lot of users, so for batching thing what we can do is we will send the first 100 users, and then what this notification service can do is it can again push the task to this queue that send notification to the remaining user IDs by specifying that in a list. So it will keep on batching again and again. So this is one thing. And a second way will be, instead of using a push mechanism, so earlier we were using this WebSockets, we were basically pushing the things here. So what we can do is we can use a hybrid kind of mode, and what it suggests is basically if there are a lot of followers or a lot of people who have to send the notifications, then you can use the pull model, and if there are small number of users, then you can use a push mechanism. Okay, but since I'm talking about here, lot of users are there to whom notifications has to be sent, so we will use this pull mechanism. What this will do is basically, once this notification service will receive what notification has to be sent, it will create the database records, so it will be there in DB, right? So what it will do is basically these users will use a polling mechanism. Okay, after every 10 seconds or after every 1 minute or whatever duration you want, they will keep on hitting the server to retrieve those notifications. If there are new notifications, then they can receive those notifications. So this is called as a polling mechanism. So now I think we have a very clear understanding of how we will create this notification and all that stuff. And one more thing that I want to discuss is about this user feed update. So whenever this user will create a post, right, basically the people who are following this user, their user feed has to be updated, right? So they already have made a WebSocket connection with the server. Those users have to be notified, right, that like some new posts have arrived, because when you scroll Instagram, right, but instantly you receive an pop-up that some new posts have arrived, so that you can scroll again to get the latest posts. So first thing is, like, of course this WebSocket mechanism will work, and once you get that notification pop-up, what you can do is you can scroll again and hit the post user feed endpoint again to retrieve only those records which have created at greater than the last post created at. Basically, suppose let's say last time you hit the user feed endpoint, you got some set of rows, and at the top, because these were sorted in descending order, this will be having the greatest time stamp, of course. So you will be wanting only those posts which are created after this timestamp. So you will use this here. So this is how you can actually update the user feed also. But of course, this will be slow because first of all, it will query the DB to get all the people you follow and then get the posts. So it involves two database queries, and also you will be sorting the response. So of course, merging plus sorting. So it is a very heavy DB operation. Later on, we will also see how to make this more efficient. So right now, you are basically what you were doing was you were starting the every service by your own, like starting this web server, then Nginx, then this notification part, these background workers, this task scheduling worker, and these queue service, this RDS all by your own, right? Separately. So this is a very cumbersome process, right? What if you can start this just by one command? So that is possible using Docker now. So now we will be talking about Docker containers, how you can actually package your application using Docker and start your application just hitting one command. So here comes the role of Docker. So now what you can do is you can package your application inside a Docker container, and inside the Docker compose file you can specify all your services to run basically, and you will also have one more file that is called as Docker file where you will specify all the requirements and dependencies. And then what you can do is you can start that Docker container over a AWS instance. So you will basically clone that repo and you will run one command, Docker compose up, and everything will start working automatically. All these services will start automatically. So there is no need to start everything by your own. So I think when you are launching your MVP, you are good to go. Of course, you can adjust these things by your own according to your use case, but I think I have given you a brief idea about how everything is working. Now what we will do is we will try to scale this application. So now suppose let's say now you have launched your application and you have got a good response, and now you are thinking of scaling this application to handle more high traffic or more high volume. So how will you scale this application? What steps you will follow? So we will talk about that now. Suppose this is a single virtual machine, and let's name it. Let's name this container as Docker container. This is A, and this is running on your one virtual machine, and this is a separate DB. What you can do is you can create one more virtual machine, you can create one more instance, and you can directly clone this repo, and instead of starting these services like all these functionalities one by one, what you can do is you can use the Docker image and start this container here. This is A, and of course this will be communicating with the same DB. But now your users, how will they know to which service to communicate to? Because now there are two instances running, right? This is AWS EC2 1, now this is EC2 2, and the same Docker container is running over both the virtual machines. So where will your user will reach? Here or here? So now here comes the role of load balancer. So we will have to use a load balancer here. So what this will do is basically, first of all, your users will basically hit this load balancer, and basically then this load balancer will route the traffic to this or this according to the load. So now we will use a load balancer here. But now the problem will come here with this notification part. Now this notification part is running here also and here also. So now what will happen is, suppose let's say this user 1 comes and this load balancer routed that request to this instance 1, okay, and this instance 1 directed that user to this notification part to make a WebSocket connection, and it has successfully made that, good. But now suppose let's say user 2 comes and hits this load balancer, but now this time load balancer routes the traffic to this, and basically he is requesting to create a new post. And now one new post is created here, and DB record will be created in the common DB. And now to basically send the notification, the post here said this notification thing that now you send the notification. But now since this notification part is unaware about the WebSocket connection with this user 1, it will not be able to send this user 1 the notification because this user 1 made the WebSocket connection with the notification part of the instance 1. So here comes the issue. So what we will do is, instead of placing notification here, we will separate this out. Now notification service is running independently on a different AWS machine. This is third instance. Now we have completely shifted this notification to a different server, and this notification will also use basically, because we are using this queue mechanism to push the notification to this notification service, we will also need notification here. We will also need a queue kind of system here also. And this queue was also being used by the background workers here and here also. So what we can do is, we can also remove this queue part from here. We can use a global queue server which will be here. Suppose let's say this is a RabbitMQ server which is running on a different AWS machine. Or what you can do is, you can use a AWS SQS service, which is separate thing, like AWS provides RDS service. Similarly, you can use that also. But now I am using a separate AWS machine, basically EC2 instance 4, and inside that one queue will be running, and this also will be using this queue, and this will be listening to this queue. And here also this task scheduling and background worker will be using this queue, and also this thing and this thing to push notifications, they will also use this queue. Not this queue, basically if you have created a separate queue inside this server, then you will push the notification to this queue, and this also will push the notification to this queue, and to this queue this notification service will listen to. So this is how we can actually make a distributed kind of environment here to basically scale this notification service and also to make it available to the users. And also now, since we were using Nginx to route the traffic between this web server 1 and web server 2 for this notification part, now how will the load balancer will know where to route the traffic? Basically load balancer work is to route traffic between these two instances, right? But now suppose let's say this user wants to make a WebSocket connection. So how it will know that it has to reach this server? So then what we can do is, we can move this Nginx from here completely out and place this Nginx here. So users will first hit this Nginx, and Nginx will say, this will act as a reverse proxy. Basically this will say, if it's HTTP, then route this traffic to load balancer, and then load balancer will route the traffic accordingly to these two different machines according to the load. And if it's WebSocket, then it will route the traffic to this instance. So we have now moved completely this notification thing out of the box, and this queue also out of the box, and this Nginx also out of the box. And now it's your choice to use the common DB for this notification service also, or you can also use a separate DB for this, completely separate. Because since we were using a single sign-on, and in the meantime you have already learned how to create a single sign-on application, because here there is no need of the user details to be stored here, because we were using the JWT token authentication mechanism and we were using the private key and public key mechanism to authenticate the user. There is no need for user details to be actually stored in this DB, right? We have already authenticated the user on the basis of that private key and public key. So you can completely separate this DB out, and you have also learned how to create a single sign-on. And instead of breaking all these things like out of the box, what you can do is one thing before actually making a lot of microservices, what you can do is first make sure that you are using your virtual machine to the maximum potential by seeing the stats. You can make sure that you are using the CPU and RAM of the system completely. If you are crossing that, then you can actually switch to this kind of a microservice architecture. And also what you can do is at code level, what you can make sure that you can use multi-threading. Like before actually moving these services out of the box, you can use multi-threading, multi-processing and asynchronous programming at code level. And also what you can do is, if you have not reached the maximum potential of your system, of your virtual machine, and you can also do vertical scaling also, like adding some resources, or what you can do is you can basically increase the number of workers of your system, of your application. Increase number of workers. Suppose let's say earlier only one process was running on your system. What you can do is you can run this same process side by side, like 4 workers of this whole thing. Or what you can, and one more thing that people usually neglect, and that is indexing. This indexing also plays a very important role, because whenever you are making any read operation on the DB, whenever you are retrieving some records or making a read operations on this DB, what you can do is you can see with what fields I am actually querying the DB. Whenever you make a read operation on DB, you do like this, select this from this table where this thing equals to this, or where combination of this fields is equal to this. So in that case, what you can do is you can index those fields, because after you have indexed those fields, it actually increases the speed of those retrievals. So that will highly increase the efficiency of your system. So you can take these things into account and then actually break the system. And what you can do is you can break the system only when it is necessary, okay? Because this notification breaking was important here. Because if you use the load balancer and deploy this on 2 different virtual machines, then notification part will not be working properly. So break the system only when it's actually necessary, okay? There is no need to break it in starting itself. Now you can notice that this notification service is running separately, right? With a separate DB. Now you can actually scale this WebSocket service. Now I will talk about how to scale a WebSocket service, okay? How you can scale your WebSocket service actually, because scaling this is easy, right? But you cannot scale this horizontally in a very simple fashion. So we will talk about that now. So now I have basically reduced this diagram to a more compact version, because there were a lot of things that were not required right now, because we have already covered them. Now just to make a conclusion type of diagram, I have finalized this diagram, which has a load balancer, this reverse proxy, and this 2 instances running for our main backend. Of course, you can also add more instances here and tell that to load balancer so that it can route the traffic between 3 instances. And there is one separate global RabbitMQ server, which is specifically dedicated for the queues. And there is one separate server that is for notification, which has a separate DB. Okay, and these 2 instances share a common DB. So now if you want to add any more functionality to your system, suppose let's say you later on come up with a e-commerce application also. So what you can do is, instead of now coding inside this main backend, because it has already been very complex here, what you can do is you can create a separate service, place it over separate instance, let's name it instance 5. And then since we are using a single sign-on authentication mechanism, your users can directly hit this by hitting this nginx. Okay, so now what we can do is, like when they are hitting this nginx, if they are hitting the endpoint with /main and then remaining URL, then you can route the traffic to this load balancer. And if they are hitting the endpoint like this with this thing, like HTTPS domain and then /e-commerce and some more URL, then you can route this traffic because of this and this to separate things. And this is the role of reverse proxy only. So now if the user is hitting with this endpoint, then you can route the traffic to this e-commerce thing. And this will have a separate DB, of course, now, because I think now you will be capable enough to have so many instances. And of course, this will be packaged using Docker. And now I think now you can actually create separate microservices, because now I think you will be in a stable condition and you will be having enough money also to create this infrastructure. And now what you can do is, and since we were using a single sign-on mechanism, right, using the private key and public key authentication, you can here also authenticate the user accordingly, because here also we were using the single sign-on to authenticate the user. Here you can similarly use the same kind of authentication mechanism, because of course when the user will hit the private endpoint, it will pass the front end will pass the JWT token with that. So here also you can decrypt the token, and also here you will place the same public key which was here also, but the private key will be here only, here and here basically, because signing of that token will happen from here itself, but that verification can be happen basically to authenticate that user can happen in any other service. So there will be no need for e-commerce service to depend on this main backend for just user authentication. So this is the beauty of JWT token authentication mechanism, which is highly helpful in creating multiple microservices. This is how you can add as much services you want. Now we will talk about how to scale this notification service. Now it was possible to create as many instances here, but now suppose let's say you package this notification service using Docker, and similarly you created one more instance, clone this repo, notification service. Okay, using Docker, you started this is instance 6, and this will be sharing a DB here. So now the request will go to Nginx and then load balancer, and this Nginx will basically route the WebSocket traffic here to this notification service, right? Now how will this reverse proxy will actually know that to which notification service it has to forward that? So you can again have to use a load balancer here. Let's name it load balancer to route the traffic to this and this. Similarly, we were using load balancer here also, right? So we will have to use the load balancer here also to route the traffic between these two instances. So now suppose let's say this user 1 and this user 2. User 1 makes the connection with this service, and this user 2 makes the connection with the second service. Now this user 3 comes and posts something, and these two users are following this user. So and this thing goes to, suppose let's say he makes the post, it arrives here on this main backend, and this main backend pushes that like this notification has to be sent to the users, so it pushes that to this queue, and this queue, from this queue it is received by, basically this is also listening and this is also listening to the same queue, right? So this notification is listening to that, this notification service is listening to this queue, and it has received this notification and it has removed that specific message from this queue. So first problem is, once this is consumed by this notification service is not aware about that, right? So this notification 1 has the connection with the user 1, so user 1 receives the notification, but this user 2 connection information was stored inside this notification 2 service. So since this notification do not have that notification message, this user 2 will not receive that notification. So how to solve this problem now? So what we can do is, basically how this RabbitMQ works is, it has one exchange, okay, and with this exchange there can be as many queues you want to associate to. So there can be as many queues you want, okay, as many queues you want. So what happens is, when this main backend pushes the message to queue, it will not actually push to queue, it will push to the exchange, okay, it will push that message to this exchange. And these consumers, suppose let's say this notification service also is subscribed to this exchange, what they can do is they can make their separate queue. Suppose this is for notification 2 service, and this queue is for this service. So what we will do is, instead of here, let me create the queue here, okay, and these two queues will have a common exchange, okay, this is for first and this is for second. So instead of listening from this queue, this will listen from this queue. So whatever message will be pushed to this exchange, it will be coming to both the queues. So this queue will receive from, so this notification service will receive from this queue, and this notification service will receive from this queue. So in this way, both the users will get the notification, right? And this is how we can actually scale this notification service also. Yeah, like by creating, so whenever we create a new notification service instance, it will automatically create a new queue to listen to this exchange. So this is a mechanism specific to RabbitMQ. So it might be different for different message brokers, but I'm talking about RabbitMQ right now. And this is one way to scale the WebSocket server. And one thing you might have noticed here is that you have to use different load balancer for this thing and this thing, right? Instead of that what you can do is you can use, instead of using two separate load balancers right now, what you can do is you can use a common thing that is called as API, that is called as gateway. Now this gateway will perform both the operations of reverse proxy and these load balancers. What it will do is, suppose this request comes, and if it's HTTP, then it will forward that request to the dedicated servers. So we will specify that if the request is for WebSocket protocol, then forward these requests either to this IP address or this IP address. All right. And now if it's HTTP request, then if it's coming with main, then forward these two instances, main backend. And if it's coming for e-commerce, then you have to forward this to this service. Basically, you have to specify the IP address. So this will perform both the operations of reverse proxy and load balancing also. Now you must have remembered about this user feed thing, right? Now what we will do is we will try to make this user feed part more efficient and more fast, because earlier we were querying the DB and performing merging and sorting and all that stuff, which was making the request very slow. So we will try to make that more efficient. So now let's talk about this user feed part that was in the main backend thing, right? So what earlier was happening was, whenever user 1 requests for the user feed, then what was happening was, first of all, it will hit the DB, get all the users which this user follows, and after that it will again hit the DB to get all the posts that were created by those users and sort them in descending order and give them first to 20. So now to increase the speed of this, what we can do is we can store this user feed. We can use basically a method called as pre-computation. For this, what we can do is we can use a caching mechanism. Now you can also use in-memory cache, like will be stored on this server itself. So first time when the user will hit the API to get a user feed, what you will do is, first of all, get all users which are followed by requester. All right. Once you have got that, you will get all the, because it's inside the same DB, you can perform directly all the DB operations from this thing directly to this DB, and then you can get all the posts and then sort them, right? So what you can do is you can get all posts, not all posts, basically you will have a limit here. Suppose let's say we have retrieved around 50 posts, okay? 50 posts we have retrieved from this DB, and we have made a user feed in a structured fashion, and we have stored all this information, this retrieved information, inside this local cache, like in memory basically. And then we will not send all these 50 posts together. What we will do is, this will be returned, only 20 posts we have returned. All right. So now the user will scroll down basically and now request for another 20 posts. So now instead of querying this DB, what we can do is we can first check whether this next 20 posts are available in this cache or not. And since cache stores the values in a key value format, the key can be, you can make customizes by your own, but let's say right now the key is user feed underscore UUID of the user, okay, to make it unique. So now you will check, okay, data is there, you will send the next 20. But now suppose, let's say you have virtual machine 1 and you also have virtual machine 2, and similarly you have 3-4 more instances of this same service which have its own local cache. So now suppose, let's say user 1 hits the first virtual machine for the first time and the information will be stored inside this. Now the user 1, next time this gateway routed this traffic to second instance. Now inside this it will have the local cache, right? So this cache will not have that information. So now to avoid this case, because now again it will query the DB and again it will slow down the process, what we can do is, instead of depending on this cache, we can make a global cache. We can use Redis and run this on a separate virtual machine. Okay, and this will be common to this and this. So when the user requests for the first time, these 50 posts will be stored inside this Redis cache. So in this way it will be more fast, because accessing the information stored on Redis cache is more faster than actually accessing the DB. So this is resolved. But now suppose, let's say user 1 requested for the user feed at T timestamp. Now user 2 comes and he posts something, okay, and now basically how will you update the user feed of this user 1? And this notification part we have already covered, like how will you send the notification to this user. But is there any way? So suppose, let's say he has got the notification also that some new posts have been made. You can scroll up to refresh the user feed to get the latest posts. But now when you will again do that refresh, it will again check the cache basically here, and it will say that the posts are not available after that, right? Because you will be storing 50 posts in descending order, but now you have to send the posts which are above here, right? Which are created after these posts, which is not present here. So again you will hit the DB, right? And again get those records, which is also very slow. Is there any way you can actually update the cache directly whenever the user posts something? So yes, that is possible. What you can do is, whenever the user, suppose let's say user 2 post something, okay, there will be a post service here, like post basically the module we can say, because this is a full single process here. Right now we have not distributed in a separate microservice. Now they share a common DB and there is a post service here. Now what this post module can do is, once the user makes any post, it can notify this user feed that user 2 has posted something. So whoever follows this user 2, suppose user 1 follows this user 2, right? So it will basically notify user feed as well, and also notification service to basically send the notification to this user 1. This part we have already covered, right? Like if there are few followers, then we can use a push mechanism, and if there are a lot of users, then we can use a pull mechanism. So one thing is that, now if I talk about how you will update this user feed inside this Redis cache, first this notify will work. So what user feed will do is, it will find out all the followers of this user 2, or even post can send that to user feed. And then what it can do is, inside this Redis cache, it will find out the user feed of all those users. It can directly update those Redis caches. Okay, but now you will say that this Redis cache can bombard because of so much data abrasion, right? So what you can do is, you can use LRU mechanism here, basically LRU eviction policy. What it will do is, this LRU means is least recently used. So suppose let's say this is a user 3. This also follows this user 2. So when the user feed will find out how many followers are there of user 2, it will have a list of user 1 and user 3 as well. But now it will check the Redis cache of whom user feeds are there. So suppose let's say user 1 feed is find out, cool. But this user 3 hardly logins to the app, okay? Hardly he opens the app. So his cache, his user feed will be updated very less. What this Redis will do is, it will automatically remove those user feeds periodically. Okay, it will check which are frequently used data, which is not frequently used. So user 3 user feed was not frequently used. So what it will do is it will remove the user feed of user 3. So this user feed will say, I found out only user feed of this user 1. So it will update the user feed of only user 1. User 3, when he will log in again, then it will again go through the same process, like get all the users and then get posts, then his cache will be updated. So again the same process will be repeated again when the user 3 will log in again. Okay, so that is how least recently used cache works. Now you might also want to completely separate this user feed out of the box, and yes, you can do that, of course. So instead of here and here, what you can do is you can create a separate virtual machine for specifically this user feed. This is virtual machine and this is user feed service, which is linked to this Redis cache. And no need for DB here because we are not storing this user feed in the DB, we are storing this in Redis cache. So now what will happen is, if first time the user hits this gateway to get the user feed, it will basically forward the request to this user feed service, and user feed service will check the Redis cache first. If it's not there, then what it will do is it will hit this main backend. First it will get all the users which are followed by the requester. It will get it from this main backend. It will query its DB and return the response, and then after getting that list, it will again hit this thing to get all the posts that were made by these users. So 2 HTTP calls, and then after making a response of 50 posts, it will store in Redis cache and give first 20, and then if any other user posts anything, then accordingly this Redis cache will be updated. Basically this post service will notify this user feed service to update the Redis cache. Okay, and Redis cache will be updated for only those whose user feeds are available in this cache, and this cache will work according to the LRU eviction policy. And similarly, we can scale this user feed service separately by increasing horizontally also. We can deploy this user feed service on a different virtual machine, which will be load balanced by this gateway, and they all will be linked to a common global cache. So this is what I wanted to talk about in this full video of system design for starting up. So I think in this video I have covered everything about how to create an MVP, all points and edge cases that you have to take care about while you are designing a robust and critical systems, like when we talk about that payments part, right? And how to scale notification or WebSocket server, how to make this user feed service and use this least recently used caching mechanism. Also we talked about how to use push or pull mechanism and hybrid model in case of this notification. Also we talked about how to use Nginx as a reverse proxy, this gateway, how to scale it progressively, and how to add new features slowly, and how to break your single monolith service into multiple microservices. We talked about message brokers, how to handle acknowledgement and how to handle idempotent tasks. We talked about message brokers. We talked about background workers and background processing. One thing that is left is how to scale this DB. So that we will cover in some other video. Also I talked about how to package your application using Docker. One thing that is left is, so basically here you are creating this virtual machine by your own, right? Like first creating virtual machine and then cloning that repo and then separately creating this gateway. So all these things, infrastructure you are creating by your own, right? So this also can be automated by using Terraform and using pipelines, and you can automate all this deployment and all that stuff using CI/CD pipelines. Also you can use Docker Swarm or Kubernetes to automatically load balance and all that stuff. So that is something related to DevOps more, and about that also we might talk in some other video. But I think this was enough what I showed you in this video. If you are starting up and you want to scale also, right, to basically serve a lot of traffic. Also we talked about in this video how to create a single sign-on mechanism. There will be only one service that will be responsible for creating the tokens, and user can hit any service and that service will be able to authenticate that user even without having the access to the main DB where all the information will be stored of that user. So if you like this video, do hit the like button, and I will see you next time.